We're now going to take a look at another advanced feature of Java, which is called serialization. We're now going to take a look at another feature that involves file input and output. So if you remember, we can read from text files and we can write to text files. So we had to use the file reader class to read input from files. And then if we want to write to files, we use the print writer class. So we would open up a file, we would read stuff, maybe do some stuff with it, and we would write back. But we would have to use the file reader and print writer classes whenever we wanted to read from and write to files. A text file isn't the only type of file we can have out there. In fact, text files are sometimes called sequential files because the only way you can read from them is you start from the very beginning and just go through the file sequentially. Likewise, whenever you write to a text file, you start the very beginning and then you go all the way, or however much data you have. There are some ways where you can just tack on stuff from the end of a file, but it's not like you can pick and choose where you want to store something from a file, or you can pick and choose where you read something from a file. This is where we can take advantage of a second type of file, which is what we call a binary file. These files are a little different from our typical text files. With text files, we can read them just fine without any problems. But with a binary file, they're readable by the computer, but a human cannot read it. If you try to open up a binary file, um, depending on what type of program you use, like WordPad or some form of text editor, you're going to see a bunch of gibberish, and it's not going to make any sense to you. But a computer can read it, a program can read it just fine. It's just humans can't read it. Now, all executable programs are stored in binary files. So the .exe files, those are binary files. In some operating systems, it's actually a .bin, which stands for a binary file. That is the executable for that type of operating system. A lot of numeric data files are also stored in binary files. So these typically have the .bin format that I just mentioned before, or the .dat extension. So we have these different extensions that correspond to binary files. Sometimes they're also called data files or executable files. But these are different types of files that we cannot actually read, but computers can. Since we have a way to write up a program to read and write text files, we should be able to write up a program that reads and writes binary files, right? Well, in Java, we have this idea of serialization, which is where we would take an object of some class, it could be any class, it doesn't have to be some specific class, and we can write it to a binary file. And on the other side of that, we have what's called deserialization, and that's just simply where we would take data from a binary file and we can store it in an object of some class. So how do we actually serialize an object? Well, we're going to need some additional classes to make this work. The first class we're going to take a look at is called the file output stream. What we're going to find is this is very similar to our print writer class. The only difference is we're writing to a binary file instead of writing to a text file or a sequential file. Now, just like all of the other file IO classes, this does come from the java.io package. So we do need to make sure that we import this package in order to use the file output stream class. And all this class really does for us is it specifies the file that we want to write to, in this case, a binary file that we want to. So whenever we do create an object of this class, we do need to make sure that we pass the name of the file as an argument. So that means we have to pass some string. Let me give you an example to show you what it looks like. So here's some code that allows us to create an object of the class file output stream from a file that's called file.bin. An original name, I know, but we're just going to go with it. I broke this up into 2 lines just to make it look nice on the slide. We could easily combine this into 1 line. But the first line is a reference variable to file output stream. It's called fs. The second line is going to create an object of the class, and we're going to pass file.bin as the file that we want to actually write to. And just like the print writer class, if our file doesn't exist, it'll create the file. So in our example, if file.bin doesn't exist, it'll create file.bin. Now, with that said, even though it'll create the file even if it doesn't exist, we still have to catch the file not found exception. I don't know why it requires it, it just does. So this means we do have to include a try-catch block where we try to create this object, and then if the file not found exception happens, we should be able to catch it and do something with it. So hopefully you remember try-catch blocks. If not, you might want to review the material for it. And then once we've done that, we can do all sorts of writing to the file. We'll talk a little bit more about how we would actually do the writing just a little bit. But when we're done with all the writing, we do have to call the close method. So in our example here, we would have fs.close to say that we're done writing to the file. The second class you need for serialization is the object output stream class. This also comes from the java.io package, but you should have already imported this when you were using the file output stream class. What makes this different from the PrintWriter class is that this class actually handles the writing to a file. So with sequential and text files, you would just create an object of the PrintWriter class, and that was it. That would take care of all the writing to the file. For serialization or writing to binary files, you need two classes. You first need the file output stream class to actually say, I want to write to this binary file, and then the object output stream class actually handles all of the writing. So this class contains all of the methods. So it handles all the printed data types, all the objects. It has all these methods for writing to an output stream. Now, what is an output stream? Think of it kind of like this buffer where we put all of the contents into the buffer, and then when we're ready, everything in the buffer gets written to the file. So basically what we're doing here is we put everything in there and then everything gets written to the file as is. So it looks just as if we were writing directly to the file. Now to use this class, we have to pass an object of the file output stream class. So that's going to be our argument. So let me give you an example of that. So we would have first our reference variable. So we would have object output stream. Maybe I'll call it OS. And then we need to create a new object of the class and pass an object of the file output stream. So if we use our earlier example where fs was an object of the file output stream class, I can just pass fs as my argument here. So then I got my object, the address is stored in OS, and then I use the OS object to handle all of the writing to the binary file. There are several methods that let us write to the output stream. Now this is not a complete list of methods, but these are some of the more common methods that you may use if you're trying to write to a file or write to the output stream. So we first have the write Boolean method. So we pass some Boolean value and we're simply just writing that Boolean value to our file or to our output stream. We have the write character or write char or write char, however you want to pronounce it, but we have this method. We pass in some value, and this is going to write a 16-bit character to our file. We have the write characters method or write chars or chars or however you want to pronounce it, and this is simply going to write a string to our file, and this is done by writing a sequence of characters. So we don't have a write string method, but we do have a write chars method. And then we also have a write double method, and you can guess this writes a double. Specifically, this will write a 64-bit double. We also have the write int method, which passes an integer value. So this simply is going to write a 32-bit integer. Now you might be thinking, wait a minute, in the previous slide, the write char method also required an integer as a parameter, and that was not a typo. For the write char method, even though it's asking for an integer, you can pass a character. It is a 16-bit character. The short answer as to why this is the reason is a long time ago, there was not a character data type. You just use integers to represent characters, and they just kind of kept that same idea with the write char method. But here we are dealing with an actual integer. We also have the write object method. So this is just simply going to write some complete object. And notice that the data type for this is the object class. So I don't have to worry about what object it is. It can be any object and it'll work just fine. But we write this to the object output stream. Now I should mention that all of these methods, including the ones that I didn't get the chance to mention here, do need the IO exception caught. So whenever you're using any of these methods, you have to use a try-catch block, and then you have to make sure that you're catching the IO exception. Otherwise, you're going to get a compiler error. And then just like with the file output stream class, when you're done writing everything, you need to call the close method. So in our example, you would have os.close to close this particular object, and then you would need to use the close method from the file output stream method, or I should say class. So you're going to be calling the close method twice, one for each object.